In this video, we're going to discuss the solutions for the sample final exam on statistics. The exam contains the two parts. The first part contains 10 short answer questions, and the second part contains 11 problems. So let's go through all of them. So we are going to start from the first part. In a web-based survey, customers are asked to provide a gender, indicate the type of the data. This is the qualitative data. Which graph is best for the paired data? This is the scatter plot. A measure calculated from the population is called a parameter. The number is drawn at random from a box. Probability that this number is less than 10 is 0.2, or the chances that this number is less than 10 is 20%, means that this random number is less than 10 and its probability is equal to the 0.2. There is 10% chance that it is more than 50. It means that the probability that X is more than 50 is equal to 0.1. We need to find the probability of getting a number between 10 and 50. It is going to be finding the probability that X is between 10 and 50. So basically, it should be equal to the 0.7, so that the sum is going to be equal to the 1. So we need to answer the following questions true or false. The central limit theorem says that for the small sample sizes, the sample mean has approximately normal distribution. This is false because the central limit theorem tells us that for the big samples, when n is more than 30, the mean of the samples have the normal distribution. As the number of the degrees of freedom increase, the t-distribution gets closer and closer to the normal distribution. This is true. We've seen this during the lectures using the graphs. What is the value of the confidence level C if the t-tailed level significance is equal to the 0.1? If you remember, the confidence level is the area between the two critical points. So the level of significance is the area in one or both of the tails. So since we are given the t-tailed significance level, it means that the sum of this area and this area together is equal to the 0.1. It means that the area in between is equal to the 0.9, which is equal to the confidence level. The next question, the Shanghai municipal government would like to claim that significantly fewer than 5% of its residents drive private automobiles to work. So the claim is alternative hypothesis because it says that the proportion of the people who drive the automobiles is less than 5%. Right, and the null hypothesis is the opposite of this. It is going to be proportion is more or equal than 0.05, and this is what we have to answer here. Assume that you are testing the null hypothesis against the alternative hypothesis. Which type of the test we need to use in order to identify this? We need to always look to the sign of the alternative hypothesis. Since this is non-equality sign, it means that we need to use the t-tailed test. It is necessary to test the claim that the standard deviation of the population of IQ scores of Facebook friends is 15. When we're testing the standard deviation, hypothesis about the standard deviation, we need to use the chi-square test or chi-square distribution. So now let's go to the problem from the second section. The first two problems are about a binomial distribution and their properties. So suppose that a football player has a penalty shot percentage 74%. In a given football year, he will take 21 penalty shots. What is the average number of the successful penalty shots and the standard deviation of the successful penalty shots which he made? In order to do this, we need to write down this problem as a binomial distribution. Probability of success in each trial, so probability that he will shoot a goal in every penalty, is equal to 0.74. So he's going to make 21 trials, right? N is equal to the 21. And in order to find the mean For the binomial distribution, we just need to multiply the n to the p, which is going to be 21 multiplied to the 0.74, which is 15.54. So in order to find the sigma, we just need to multiply the n, p, and q and take the square root. So in this case, it is going to be 21 multiplied to the 0.74 multiplied to the 0.26. So if we multiply everything and take the square root, we're going to get the answer 2.01. So there are 12 questions in the section. If you guess at random the answer for every question for the section, what is the probability that you will get at least one correct answer? So let's assume there are 12 questions, and for every question there are 4 multiple choice answers. So it means that the probability that we answer correctly for every question is 1 over 4. Or we can just say that this is equal to the p. So for example, the probability of successfully answering for the question, if it has 4 multiple choice answers, is going to be 1 over 4. If it has 5 multiple choice answers, is going to be 1 over 5. If it has 6, 1 over 6, and so on. So at this stage, we can solve this problem symbolically as well. So, and the q is going to be equal to the 1 minus p. So we need to find the probability that we will get at least one correct answer. So let's say x is the number of the correct answers for these 12 questions. In this case, it is going to have the binomial distribution. Was the probability of success for every trial, and n is equal to the 12. So we need to find the probability that x is more or equal to the 1, which can be found as 1 minus probability of x is less than 1, which is equal to the 1 minus probability of x is equal to the 0. So we can evaluate the probability of x is equal to the 0 using the formula for the binomial distribution, which is going to be given at the end of this exam paper sheet. So C12, 0, P in a pair of 0, Q in a pair of 12. So we need to answer 0 answers correctly and 12 answers incorrectly. So which is going to be 1 multiplied to the 1 multiplied to the q in a pair of 12. So we just need to substitute this here. It is going to be 1 minus q in a pair of 12. So this is going to be the answer. Depending on the p, this q is going to be different. For example, if the p is equal to the 1 over 4, then q is going to be equal to the 3 over 4. So let's go to the problem number 3. So the newspaper article reports that in a poll of 120 randomly selected eligible voters, 55% say that they are going to support the candidate A in the elections. There are 2 candidates running. So the result was inaccurate of 3%. So what confidence level did they use for their research? So please remember, so in order to make the confidence intervals for the proportion, we need to use the error margin formula, which is going to be critical point multiplied to the p hat, q hat divided to the n, and we can find the level of confidence by finding the critical point. So here we have all the ingredients except this critical point, and we're going to find this. So we're given that the error margin is equal to the 0.03, 3%, it means 0.03. P hat is equal to the 0.55, it means that the probability of people who are supporting the candidate A is 55%. Q hat is equal to the 0.45, N is equal to the 120, and we just need to find this Z from here. So if you find the Z from here, it is going to be Z critical point from here. It's going to be E multiplied to the square root of N divided to the P hat, Q hat. So if I put all the numbers here, it's going to be 0.03 multiplied to the 120 divided to the 0.55 multiplied to the 0.45. It is going to be 0.66. So this is the critical point, and we need to find the level of confidence, right? So the critical point here is given. So we know that the negative critical point is going to be minus ZC simply. So if you have the table for the Z distribution for the negative values, you can just find the cumulative area until here, right? And you can find this area in between these 2 critical points. Since we have the Z table only for the positive critical points, what we're going to do is we're going to find the area until here. If we subtract this from the 1, it is going to give us the area here. Since we know the area here, we can find the area here, then you can find the area here. So let's find this area, which is going to be 1 minus phi of 0.66. So since this critical point is 0.66, basically we're finding the area until this point, and we're subtracting this from the 1 in order to find this area. So the phi of 0.66 can be found from the table. So we need to go to the table and find a value of the area for the 0.66, which is going to be 0.745. 0.745 roughly. 0.745. 1 minus phi of 0.66, it's going to be 0.225 roughly. So this area is also going to be 0.225. In order to find this area in the middle, it is going to be 1 minus 0.225 minus this area 0.225, which is going to be roughly 0.49. So the area here is equal to the 0.49, which means that the confidence level which is used in this research is 49%. Problem number 4 is about the normal distribution. The average grade points for the large population has a normal distribution. XA has a normal distribution. Was the mean 2.2 and the standard deviation 0.6. Suppose that 4 students are randomly selected from the student body. What is the probability that their average grade points is above 2.91? So basically, the average of the sample again has a normal distribution according to the central limit theorem. So if we are drawing the sample from the normal distribution, so probability that this average is more than 2.91 is going to be equal that the probability of the Z is more than 2.91 minus 2.2, so X minus mu divided to the sigma divided to the square root of n, which is going to be simply 2. So basically, when we find this Z value for this point, it's going to be X minus mu divided to the sigma divided to the square root of n according to the central limit theorem. So this is going to be 2.91, which is given, minus mu is 2.2, sigma is 0.6, n is 4, square root of n is 2. If you calculate this, it is going to be 2.36. Probability that Z is more than 2.36, it is going to be, so basically what we have to do is, we're given the critical point, which is 2.36. Probability that Z is bigger than this, it means that we need to find this area, which is going to be 1 minus the area until this point, phi of 2.36, which is going to be roughly, so this area is equal to 0.013 from the table, right? So we can go to the table and find this area one more time. So 2.36, 2.3, 0, 1, 2, 3, 4, 5, 6. So this is going to be 0.99. 2.36, 0.990. Sorry, this is going to be 0.990 roughly. So if we subtract this from the 1, it is going to be 0.01 roughly. Let's go to the next problem. So how large the sample should be taken to estimate the population proportion within the error margin 3% at the 95% confidence level. So again, we need to remember this formula for the error margin for the population proportion. So this is the critical point multiplied to the p hat, q hat divided to the n. Let's square both of the sides. It's going to be e squared is equal to the zc squared p hat q hat divided to the n. If you find the n from here, it is going to be z squared multiplied to the p hat q hat divided to the e and the square. We just need to put all the numbers and find the n. So in this case, e is given as 0.03. Since we're not given p hat and q hat, we're just going to take them to be equal to 0.5. And the critical point is going to be found using the confidence level. So we are given 95% confidence level. It means that the area between the two critical points is equal to 0.95. So it means that this area here is equal to 0.025 and this area is here 0.025. So we need to find the critical point ZC, so which corresponds that the area until the ZC is equal to 0.975, and we can find this critical point. So again, we need to go to the table, we need to find the area, which is 0.975, which is here, right? So if you find the z, it's going to be 1.9, and this is going to be 6. It means 1.96. So the critical point is 1.96. So basically the area until 1.96 is equal to the 0.975. So we just need to put this here. So that C is equal to the 1.96. So if we put everything to here, 1.96 in the square, multiplied to the 0.5 in the square, divided to the 0.03 in the square, it is going to be equal to the 1067.1. It means that we need to take at least 1068 people to our sample in order to make this kind of estimate. Problem number 6 and 7 are about the correlation coefficient and the regression line. Researchers is interested in determining if one can predict the gasoline efficiency from the speed of vehicle. So basically you need to create the regression line. So y hat is equal to the mx plus b. So where you can put here the speed instead of x, it is going to give you the y, the efficiency. So basically how much gasoline it uses depending on the speed, right? So independent variable here is always the x, because you choose what is the x by yourself, you substitute this to this equation, and it is going to give you the y. So what is the explanatory independent variable here? It's the speed of vehicle. And dependent variable is going to be the efficiency of the gasoline. For a given independent variable x and dependent variable y, it is known the following information. We need to find the correlation coefficient, and we're just going to use the formula for this correlation coefficient. R is equal to n multiplied to the sum of x, y, minus sum of x, sum of y, divided to the square root of n multiplied to the sum of x squared, minus sum of x in the square from the square root, multiplied to the n multiplied to the sum of y squared, minus sum of y in the square. So we're given all the ingredients here, right? So let's put together everything. So n is given to be equal to the 20, sum of xy is equal to the 150.5, minus sum of x is 25.4, sum of y is 22.6, divided to the square root of 20, multiplied to the sum of x squared is 145.7, minus sum of x, 25.4 in the square, right? Sum of x in the square, multiplied to, again, 20 multiplied to the sum of y squared, 196.5 0.2 minus sum of y, which is 22.6 to 20.2.6 in the square. So if we calculate everything together, it's going to be 0.875 roughly. So in the second problem, in the second part, we need to find a regression line. So we're going to find this using this equation mx plus b, where m, which is the slope of the line, can be found using the formula n multiplied to the sum of x, y minus sum of x, sum of y, divided to the n x squared minus sum of x in the square. So we just again put all the numbers together. Divided to the 20 multiplied to the 145.7 minus 25.4 in the square. If we put together everything, it is going to be 1.0737. And we can find a b by putting the formula y bar. It means that the average of the y minus m multiplied to the x bar. So y bar is going to be the sum of the y divided to the n minus m multiplied to the sum of the x divided to the n. So let's put them together. So the sum of the y is 22.6 divided to the 20 minus 1.0737 multiplied to the sum of x, which is 25.4 divided to the 20. If we put together everything, is going to be minus 0.2336. So the regression line is going to be 1.0737x minus 0.2336. So let's go to the problem number 8. It is about the goodness of fit test. So the analysis of the police department shows that the distribution of 840 robberies over the weekdays is given as this table. What we need to do is we need to test the hypothesis that the distribution of the robberies per week is not uniformly distributed at the significance level. So the claim is telling you, so the expected frequency is going to be the uniform distribution over the weekdays. It means that for every day it is going to have the same number of the robberies as for another day. So basically we need to divide 840, which is the number of the robberies for all the days, to the 7, which is going to be 120, right? So the claim tells you that the observed frequency is not equal to the expected frequency, and this is going to be the alternative hypothesis, and this is our claim. And the null hypothesis tells that which is going to be opposite of this, the observed one is equal to the expected one. So expected one is going to be 120 for all the days. The uniform distribution of the number of the robberies for all the days. So what is the value of the test statistic? So the value of the test statistic for the goodness of fit test, it is going to be the sum of the O minus E in the square divided to the E. Right? So for each E in this case, but since each E is equal to the 120, we can take out the 120 from the brackets. So the x squared is going to be 120. So we need to find the difference between 105 and 120, which is going to be 15, right? And we need to square them. So 15 in the square plus the difference between them is 1 in the square. Difference between them is 9 in the square. The difference between them is 5 in the square. The difference between them is 10 in the square. The difference between them is 14 in the square. The difference between them is 6 in the square. So if we square everything and sum them, it is going to be 664 divided to the 120. It's going to be 5.53. This is the test statistic. So in order to find the right critical point, we need to find the degrees of freedom. So which is going to be number of the categories minus 1. So in this case, it's going to be 7 minus 1, which is 6. So the level of significance is given 0.1. We just need to go to the table for the chi-square distribution. We need to find the degrees of freedom 6 and alpha equal to the 0.1. And we find that the critical point, the right critical point, is equal to the 10.65. So basically 10.65 is here, and this is going to be the rejection region, and our test statistic is 5.53 is not in the rejection region. It means that the null hypothesis is not rejected. right? So let's go to our claim. The claim tells us that this is not uniformly distributed, right? It means that our claim is the alternative hypothesis. Since we're not rejecting the null hypothesis, it means that we're not supporting the alternative hypothesis. So we need to choose this answer. At the level of significance 10%, there is not enough evidence to support the claim. Problem number 9 is about a confidence interval for the population proportion, which is a really straightforward problem. In a sample random variable, in the sample random survey of 89 teachers, 73 said that they are satisfied with the semester, established 98% confidence interval for the population proportion for all the teachers from the school. So the proportion of the teachers who are satisfied with the semester is going to be 73 over 89, which is going to be 0.82. The Q hat is going to be 1 minus P hat, which is going to be 0.18. So the error margin, which we need to calculate, is going to be the critical point multiplied to the P hat, Q hat, divided to the N. So we can find this critical point for the 98% of the confidence level the same way as we did before. So this is going to be 2.33 multiplied to the 0.82, 0.18 divided to the 89. If we calculate everything, it's going to be roughly 0.095. The confidence level is going to be 0.82 plus minus 0.095. So basically the population proportion of the school teachers who are satisfied with the semester is within this interval. Basically 0.82 minus 0.095 and 0.82 plus 0.095 within this interval. Problem number 10 is we need to create the regression line. So the parents of the girl recorded the height at the various ages up to 66 months. Below the table has the all the records. So what we need to do is we need to know, so we just would like to create the regression line. Y is equal to the mx plus b. The first question is which variable is the most appropriate for the independent variable, right? So the independent variable would be, for example, the age, because if you put the age, it should give you the height, right? So you recorded the age and the height of the girl for every month. So in the next, you would be interested to predict the height of this girl depending on the age, right? So the age is independent variable. Age is x. And the height is going to be equal to the y. So in order to create the regression line or the correlation coefficient, we just need to fill out this table by multiplying every age to itself, every age to the height, and every height to itself. We can fill this table, and in total we can get this sum, right? So in our case, so this is going to be the sum of the x, this is going to be the sum of the y, this is going to be sum of the x squared, this is sum of the y squared, this is sum of the x multiplied to the y. So again, in order to calculate the correlation coefficient, we just need to use this big formula. So n multiplied to the sum of xy minus sum of x, sum of y, divided to the square root of n multiplied to the sum of x squared minus sum of x in the square from the square root multiplied to the n of sum of y squared minus sum of y in the square. If we put all of these numbers, which we have calculated already, to this formula, we will get roughly 2,484 divided to the 2,491, which is 0.997. So now we need to calculate the correlation, the regression line. So y is equal to mx plus b. So the m again is going to be calculated using this formula, so which is going to be very similar to this, except this part and only this part. So which is going to be 2,484 divided to the 2,776, which is going to be 0.8948. And we can find that the b, which is going to be the sum of the y divided to the n. N in our case is going to be 1, 2, 3, 4, 5. 5 minus m, which we have calculated just now, multiplied to the sum of the x divided to the 5 again. It is going to be 55.71. So now we put together these two numbers. It is going to be 0.89 multiplied to the x plus 55.71. We can predict the height of the girl depending on its age. So if you put the age to the x, it is going to give you the predicted value for the height. And the last problem is about the properties of the expected value and the variance. So we know that the formula for the x minus 1 in the square, it's going to be x squared minus 2x multiplied to the 1 plus 1 in the square, which is simply 1. So we can open up the expectation and apply this. It is going to be expectation of the x squared minus 2 expectation of the x plus 1, because the expectation of the constant is simply a constant, is equal to the 11. So the expectation of the x squared minus 4x plus 4 is equal to the expectation of the x squared minus 4, the expectation of the x plus 4 is equal to the 6. So we've got a system. We just need to find the e of x and e of x squared from here. So the expectation of the x squared minus 2 expectation of the x is equal to the 10. The expectation of the x squared minus 4, the expectation of the x is equal to the 2. So in order to find the expectation of the x, we are going to subtract them. It is going to be 2, the expectation of the x is equal to the 8. From here we find that the expectation of the x is equal to the 4. If we substitute this to one of them, for example to here, it's going to be the expectation of the x squared minus 2 multiplied to the 4 is equal to the 10. It means that the expectation of the x squared is equal to the 18. So now we can find the expectation of the x is equal to the 4. The variance is going to be the expectation of the x squared minus the expectation of the x in the square, which is going to be 18, minus 4 in the square, which is 16, which is going to be equal to the 2. This is the solution for all the problems.